went and did this homework problem, and curious things were happening. If you run this, one thing to check, I'll show you here, is you have a window, the picture, and oops, I didn't have it in the top picture. These right here are the eigenvalues of my minimum state controller closed loop system. All right? What can you tell me about those?
It's not stable.
Not stable. In fact, what should they be if I have a controller observer? No, those eigenvalues, or really those closed loop poles, should be what? Well, the ones I defined. All right? In fact, this is the full state observer poles. It does exactly what I think it would be. It would be -1, -2, the observer should -2, -3. Those work exactly. So one thing I do to check these things, you actually set the eigenvalues of the my closed loop system, and they should be the poles that I've chosen. Why is this one doing something weird? Look at the picture. Yeah, not just a zero.
It's in the right-hand corner.
The right half plane is zero. In fact, if you look at the open loop system, all the poles are zero in the right half plane. Oh, nice and stable system. None of that in the right half plane. Remember what we call those? Right half plane zeros? No, that's stability. Non-Midland phase. Look at that term, 5200, 6200. Sure. What is a zero? You mean there are different equations. No. Derivative, but derivative of what? Easiest to see it in trigonometry. They have some equals, which would be a x over y. Cross multiply, and I'll get this. That's the effect of the zeros. It's doing what? Differentiating the input. Now this particular one is that. What does that mean? Is it still stable? Potentially this part stable? Yeah. But what would it do to the input? Say a step input. Step? What's the derivative of a step? Impulse in the opposite direction. This picture. The blue one, I think, is the no observer. Green one's the full state observer. This first problem. Give it a step input. What's it do? It goes the wrong direction first. And then finally goes up to the value. And that's the effect of that non-minimum phase zero. So starts off the wrong direction, then finally goes off to. So this is the effect of an impulse, and then the effect of the step. Okay. Yeah, that happens to cause the minimum phase observer to blow up. Can't handle it. All right. You know of an example of this kind of system? Physical example. Not just a bicycle. Actually, two-wheel vehicles, yeah, turning. You actually have to go the wrong direction to go the right direction. Same problem on a motorcycle. You might even know you can do that. Sometimes you actually have to go the wrong way, you have to go to the right way. But take away one of the wheels on the bicycle. Unicycle. How do you go forward in the unicycle? From start. I have to go backwards first and go forward. Because they have to start leading. The other way to start leading forward is to go back underneath. Another one. Anyone here do ballet at one point? Any of you guys?
Nah.
Stilts, same thing. Red points. I just start walking forward. I guess step backwards first, like lean forward, circle forward. So all non-minimum phase, we have this zero in the right half point. Right? Still stable, but causes this weird effect. So it causes the minimum order observer to blow up. So I change this slightly. I could get rid of that C11. This is what's causing the minimum order observer. Ammo, look at my eigenvalues for the minimum phase observer.
You got to do this.
Back.
One.
Just get all working out. Plot the plot. These.
Just 1, 0.
Yeah, it won't be minimum phase anymore, but.
Oh.
I took away the minimum phase, that's why it's not going to negative anymore. So it's a nice straight step input. So the, I can't remember what colors. I think the red one is the no observer. Green one, full state observer. I think the blue one is the minimum phase. So if you get weird results, it's because it's a non-minimum phase. So what's the answer? If I have non-minimum phase system, don't try to do a minimal order observer. Because full order works fine.
Yeah, I didn't divide by the DCA, but I see that you can.
I did that just to make them all go to the same scale.
Just to compare them or.
Yeah, it's, if you don't, that's is that thing about the inputs, where you have to scale the inputs, depending on what kind of feedback I have. It's a nice thing to do. It's easier to compare. That's all. Different.
Yeah, so how would you control the system that has
Non-minimum phase?
a?
Well, I would just wouldn't use the minimal order observer. Everything else works fine.
Okay.
Yeah. Full order observer, no observer works fine. It's the minimal phase one is because that C matrix is X1 plus X2. And I would say, I know what X1 is, the output is, no work. Yeah. Okay. Yeah.
About determining which states are observable or not.
Well,
in a
it's
real
coming
system.
right from practice, really. Which one can I directly measure? All right. For instance, the lab system. I have an encoder there. So obviously, which one can I directly measure? I have an encoder. Position. All right. So maybe I can't directly measure velocity because there's a technology there. It might be noisy, technology noisy, so that will make the observer. I trust the encoder, I don't trust the technology.
Are we going to do anything on counter filtering?
We'll talk about that now. So, that came up, I think there's an email too, I think there's a lot of sense. Well, what if X1 isn't the one I can directly measure? Maybe it's X1, X2, X3. X2 is the one I can directly measure. So I want to make an estimator on just X1 and X3. Yes, you can do that with the setup. The easy way to do it, however, since we have the equations all set up with A, B, you can kind of figure out what all those new ones are. My A matrix is, let's make it here. Something like this. And X2 is the one I made. Well, what's AA now? It's that one. All right, so it gets really messy if you, you can figure out what A, B, A, B, and everything are from the same. What's an easier way of doing it though? Rearrange your X1s, X2s, so instead of X2, X3 in this order, I had to rearrange it, so I put X2 on the top. To rearrange my A and B and C matrices. That's easier to do because now all my minimum order observers are all A. So if I'm always kind of putting the one I can recognize on top, life is a lot easier. That makes sense? And that's not hard to do, you can rearrange the different equations. And wait, that's a way easier than trying to figure, what's going to do A, B, A? Or this, what's going to do, you know, because they're all split up here now. Okay. Other questions on this stuff? Yes?
Yeah, I was getting confused about how to use the reg function with a minimum observer. Because
Can't.
you have less gains, right?
Can't.
And so
Cannot
what's this?
use it.
What?
Cannot use it.
Cannot use it. Okay.
No. Use
I thought you
this. Here's my minimum order observer. Oh, I just highlighted. All right. Because it's, you have to break up the A, B matrix, all these different parts, and the K's different parts. Yeah, and it works fine. Now, the one thing you might notice here is C tilde detailed it, but the minus signs, whether they should be minus or plus or something, depends on what. This is minus or plus here. All right. Some people like to assume all is minus there. Others say, no, no, I'm just going to have this as being U and go straight in there. So you'll have to see what this proper sign should be.
So which one's which then?
This one might have set up here is minus. How can you quickly tell? Well, certainly if you look at the M plot here, it's really easy. I check my eigenvalues here, and it should get what eigenvalues. The poles I set for my controller and observer. Right? So I set -1, -2 for the controller, -3 for the minimum order observer. They show up. If I swap these around, on one of these, if I use feedback, here's what I mean, I have positive sign here, it's assuming negative feedback, right? Because feedback assumes the minus sign there. If I change that, let's say I can't remember how to do that. What do I have here? Those are my poles of my closed loop minimum order controller system. Are they right? In fact, it's also unstable. I just, I hit sign wrong. So, try the other side. And, well, yeah, got it right. Same thing in the forward observer. Sometimes you get confused. It should be plus or minus. Check. I should get my, all right, it's a great way of checking I did think right. That makes sense, what the check is here? I define controller poles to be that, observer poles to be that. My controller observer should give me those poles. If they didn't, I did something wrong. There's a typo somewhere. I mean, believe me, how long I spend fixing typos. You all know you fix a lot of typos too, right?